to our popcorn absolute dating lab. So let's go over a couple of key terms we have. Absolute dating is determining the actual age of an event or object in years. There is a difference between absolute and relative dating. Relative dating is simply going to tell you whether you're older or younger than something else. For example, if I told you I was older than 2 years old, but younger than 10 years old. You don't know my exact age, but you know I'm within the range between 2 and 10. Absolute dating will tell you exactly I am 7 years old. Absolute dating is much harder to find because it is much more precise. Now, last video we talked about an isotope. Recall that an isotope, we had our carbon isotope, is going to be the same element, but they have a different number of neutrons. There are stable and unstable isotopes. A stable isotope stays in its original form, which means it cannot be broken down. An unstable isotope has the ability to break down to form a different isotope. Unstable isotopes are also being able to be called radioactive isotopes. The process of an unstable isotope breaking down is called radioactive decay. In our popcorn lab, popping of the popcorn represents radioactive decay. Half-life is the time needed for half the sample of our radioactive substance to undergo radioactive decay to form the daughter isotope. In our popcorn example, half-life would be represented by 50% of the popcorn being cooked. All right, let's talk about this a little bit more in depth. This is a picture of some isotopes. We have our top isotope, which is 100%. It is 0 half-lives in our isotope. We have 50% is the daughter. Notice that there are 8 circles in your first circle. In the second circle, 4 are colored in and 4 are not. That is 50%. That represents 1 half-life being passed. Then in your next circle, instead of 4 being filled in, there are only 2. That represents 25%, which is 2 half-lives. And finally, in our last example, instead of 2 being filled in, there's only 1, which represents 12.5%, which is 3 half-lives. So let's take a look at our bag. Which bag would represent our parent isotope? It would be bag C because none of them are popped. Bag A, B, and D are all representing a daughter isotope. Bag A is 1 half-life passed because it's 50%. Bag B would be 3 half-lives passed because it's the very bottom, 12.5%. And bag D, the 25%, would represent 2 half-lives passed. This gives us enough information to fill in our chart. Notice on each way down, it's cutting them exactly in half. So, how many half-lives do we have for bag C? 0. Half-lives for A? 1. Half-life for D? 2. And half-life for B? 3. All right, at this time you need to find the definitions for radioactive decay and radiometric dating on page 108 and 109. We remember that radioactive decay is when an unstable isotope breaks down. This is represented by the popcorn popping. Radiometric dating is finding the number of half-lives that passed. So it's us finding the age of the popcorn in minutes. Our parent isotope is the one that cannot be broken down. That is bag C. It's the unpopped popcorn. Our daughter isotopes are bag A, B, and D because they all have some popped popcorn. And then find the definition for half-life, which is on page 108, which can be represented by 50% of our popcorn being popped. Then you can find the definition for absolute dating. Remember, this one is in PQPA, so you need to say it as absolute dating is defined as, and then the definition with a period. Number 2 is a yes or no question. Does absolute dating give an exact number in years? Yes or no? And then finally, let's work on number 3. Number 3 asks if you have half-life that is 1 minute, what is the age of bag of popcorn B? Okay, so we have popcorn B. Popcorn B is at 12.5%. Recall from our chart that B has 3 half-lives passed. In the example, it's telling us that, well, half-life is 1 minute, but we have 3 of those that finished. So essentially, we will do 1 times 3, which would get us our answer, 3 minutes have passed for your answer for number 3. I hope that clears up and helps you with your lab. Make sure you have it complete and then hit turn in on Google Classroom. Thanks for watching.